Now when it comes to plane, you have another comparison now. Above the plane, below the plane also possible, right? So here I'll have collection of points which are on the plane. They are all called as coplanar points. Co means same. Planar means plane. Coplanar, same plane points. Points which lie on the same plane are called as coplanar points. Now I marked P here. Is this point P on the plane? P is not coplanar. It is outside the plane. There is some point here, Q. Is it coplanar? No, it is outside the plane. I mark R here. R is on the plane. So R is coplanar point. It lies on the plane, but P is outside. Where is P then? If it is not on the plane, where it is? It is in the space. You can reach P only by adding height to the plane. Then after some time, that plane will move through P also. Then it becomes three-dimensional. Simple. It's not on the plane. It is in the space. So write down coplanar points. The points that belong to the same plane are called as coplanar points. See, I'll show it to you from your where you are sitting there itself. You are sitting on a room, right? You have the four corners of your home. Flooring. The floor of your house. There are four corners. They are all lying on the same floor. Floor is a plane, right? Look at the corner of your home which is perpendicular to you. I mean, what I am calling is the wall, where the two walls intersect. That is also a line only. Is that line lying on the floor? Understood what I am talking? The corner of the walls. Does it lie on the floor?
No, sir.
The vertical height of your room. Does it lie on the floor?
Yes, sir.
They are non-coplanar. They don't lie on the plane. Those lines which lie on the plane, on the floor where you are sitting, draw two straight lines. They are on the floor. On the wall which is on your right side, draw a line. That line is not on the flooring. So that line is not coplanar to the floor. Floor is a plane, right? So the lines that are in the same plane, they are called coplanar lines. If you want to understand this much more better, you have a pen in your hand. Your notebook is a plane. Hold the pen with some angle to the, as if you are writing. Hold the pen on the paper, not lying on the paper. While you are writing, how you hold it. Then will it be on the plane? Pen is a line only. Notebook is a plane. But this pen, while writing, is not lying on the plane. It is not coplanar. If you place it on the notebook, you are only listening, you are not writing anything. You just place the pen on the notebook. Then the pen, which is a line, is on the plane called the notebook. Then it becomes coplanar. All English words only, sir. But while applying, they make a huge difference if we don't know what exactly the role it plays. So to understand coplanar lines, first try to understand what is non-coplanar lines. What are the lines which are not on the plane? Then it will be clear whether it lies on the plane or not. Now, what do we mean by non-collinear points? Collinear points collection is a line. Happy, no problem. What do we mean by non-collinear points? The points which do not lie on the line, which are outside the line, they are called non-collinear points. So look at the diagram and tell me, is A and C collinear? Is A and C collinear?
Yes, sir, it's collinear.
Is A and B collinear?
Sir, no. These points are not lying on the same line. So that's why I said that it's non-collinear.
No, they are lying on a line. See, that's what is the greatness. Collinearity, non-collinearity, 2 points are always collinear, right? The next property. There is something called Euclid geometry, if you recollect. There's a chapter called Euclid geometry. I don't know whether it is in 9th or 8th class. And there is something called axioms there. Which class is that Euclid geometry you came across?
Sir, the 9th.
Ninth only. Done, completed that?
Yes, sir, in school completed.
Okay. There you have a property, if you remember, there exists a unique line that always passes through two fixed points. In fact, if you axiomatize them in order, then through one point there exist only infinitely many lines. Through 2 points there will be exist only unique line. So collinear or non-collinear, I should start only talking from 3 points. If I ask you A, C, E, you can say answer is collinear. If I ask you A, B, G, you can say they are non-collinear. But if I say C, G, don't even think. 2 points will always be collinear.